Thank you everyone for coming. My name is Braden. I'm talking about debuggers and debugger visualizers today, and talking about how to make code more accessible, or how to make your code more accessible by using them. Now, I have had this slide in my talk since before I saw Kate's keynote. And in her keynote, she mentioned this talk, and I thought, wow, that's my favorite Kate Gregory talk. So now, in a current Kate Gregory talk, she is talking about my favorite Kate Gregory talk. That's kind of cool. So I really like this talk, Stop Teaching C. One of the arguments that she has in it, which I will probably butcher and paraphrase in my own words, are that an interesting way to teach new programmers how to do programming, if you're going to use C++ or any other language, but an interesting way to do it is to use a debugger. And you might want to, instead of them having to know, what does std : cout mean? What does hash include, or a new programmer might say hashtag include less than iostream, or stdio.h. Like, what do any of these things mean? If I'm writing printf, why do I have parentheses here? If I'm writing printf, why do I have %d? All of those sorts of things. You don't really have to have any of that mental burden if you just use a debugger. And you create two integers, and you just try to add them together, and you take a look in the debugger, and you just see what they are. Was that close enough to the argument? Okay, perfect. I got assent from Kate. So, great. Okay, yeah. So that's a really good reason to use a debugger. Now, flipping gears entirely, I have a scenario for all of you that some of you might have gone through, potentially some more recently than others. Let's say your program hits an error and it exits. Okay, let's build this scenario. You don't have any knowledge of where this thing happened, and you have logs, but they're too sparse to actually determine what happened. What do you do? Any takers? Any takers? Cry. I hear cry. Any other cry? Yes. Try to reproduce it. Okay, sure. So, okay, yeah, that makes sense. So are you going to need to rerun or recompile, or how are you going to do that? Rerun. Rerun? Okay. Rerun. Okay.
Formulate a hypothesis.
Formulate a hypothesis. Okay, sure. So increase the level of logging, yes. That may involve recompiling, it may involve rerunning. And even simpler than all of those, typically what I would do, simpler probably meaning worse actually, because these are all actually really good answers. I might just do some printf debugging, which is what I call it and what some of my colleagues call it, when you decide that you just want to modify the source code with a print statement or maybe an extra log statement, just adding a few extra things in there. But the problem with doing this is now you have to recompile the program. And yeah, maybe it's in a source file, but maybe it's not. Maybe it's in a header file, and now maybe you have to go up and get a cup of coffee. Maybe that's welcome, maybe that isn't. But regardless, you do have to take a break. And now, once you're back, once it's done, you rerun the program, you look for the message. And then you look for the message, and you don't find it. Or you do find it, and you find it 10,000 times. Or some other thing is wrong with the message. There's some piece of information that you're going to need from this message that wasn't there. And so, because the print statement is wrong or insufficient, you have to loop the above steps ad infinitum. So again, you go modify the source code with your newfound information, and then you recompile the program and get cup of coffee number 2, and then you rerun the program looking for the message, and then again, there's something wrong with it, so you have to keep going. And in my experience, maybe this is just me, but in my experience, because I'm recompiling on every loop, this feels like it absolutely takes forever, and it's a big waste of time. And these loops can sometimes go on for quite a long time, I'll say. So what can you do alternatively? Brainstorming the most ridiculous example that I could possibly come up with, I encourage you all to come up with something more ridiculous, is to not write bugs. So if you don't write bugs, this will not happen, I guess kind of definitionally, but it's not possible. So let's say maybe we can try to use sanitizers to reduce the bugs. That helps. It doesn't work because reducing bugs and eliminating all possible bugs are very, very different things. If the bugs still exist, you're still going to have to go through this process. Others? Other possible alternatives? Maybe I'm hinting at something in this talk. Write tests, okay. And that'll reduce bugs. Won't necessarily catch all of them, but it might have caught this one. Might not have. Maybe anything to do with this talk, potentially?
Static analyzers?
Okay, static analysis, also not to do with this talk, but yes, yeah.
You can run in debug mode and set some breakpoints.
You could run in debug mode and you can set some breakpoints. Ah, look at that. You can use a debugger to, how did you know? You're a plant. You can use a debugger to explore and walk through the code. So this is typically my next steps if I realize that, doing printf debugging is a little bit too much. So here are the pros that I find of using a debugger. No recompiling. Or, I'll correct that, you recompile at most one time, but in the steady state, when you're iterating, there's no recompiling, right? You recompile once for symbols, and that's really all you need. And that's at most once, because you might have to recompile 0 times for symbols, depending on your toolchain, or depending on what you've been doing recently. So iterating is much faster, and you can get as granular as you want. You can step into the function calls, as you do in a debugger, and you can get some really special features. Like you can have time travel debugging, you can... Oh, there was another example that I was going to say that I'm completely blanking on. But there are cool things that you can do with a lot of debuggers that allow your debugging experience to be a lot nicer than just sticking logs into some source code. Now there are some cons. It is more painful to set up a debugger. It's just another tool that you have to know. There's another learning curve. You might be using a text editor, and then you know how to use your compiler, and you know how to output that to the console. And that's the tools that you're using. To use a debugger requires an extra tool. To do printf debugging does not require an extra tool. So I understand there is a learning curve here. So it's less accessible to get started. And this could be a problem, let's say, for some people who don't know very much, or who might, feel very discouraged from, trying all these sorts of fancy tools. They don't know even how to get started. Yeah, it's just hard, so you might, go with a situation that's not as easy to use. And very importantly, you can get some incomprehensible data that gets displayed from the debugger. So what does that look like? Let me create a boost unordered set of int. I have 3 numbers, 11, 22, and 13. Can anyone tell me in Visual Studio what this is going to print in the debugger? So if anyone guessed this, this is what it shows in the debugger. Now, if anyone here can read this and pull out those numbers, now you might say, oh, you didn't expand everything enough. Well, I mean, I did, because the data isn't in the functions, right? The data is in the buckets, but I mean, there's like nothing in there. How do you read this? This is really inaccessible. Like, in order to use this data structure, if you don't already know what's going on, if you're trying to debug this, you set a breakpoint, there's nothing here. The debugger doesn't iterate over the structure. I'm picking on this one data structure in particular because I will say it actually now looks like this. Would anyone disagree that this is nicer than before? Okay. So it now looks like this as of boost 1.87, I think. So to whoever did that, sorry, it was me. So it looks like this now, and I think that's great. Now a similar thing might happen in GDB. Are you expecting it to look like this if you print it out in GDB, right? You set a breakpoint and you say, okay, what does my set look like? Print set. I had to lower the font size, but really I should have lowered the font size to way, way smaller than this because it goes down through the floor. There's so much going on here that this is incomprehensible data. So if someone is trying to use this data structure, how are they going to use this in a debugger? How do they set a breakpoint here? This is what it looks like now. This is exactly what it should be looking like because this is the data that you need from a debugger. From a user perspective, this is the kind of stuff you need to see. So basically, this talk is going to be addressing the cons of debuggers that I've been pointing out, and I'm advocating for writing code with tooling and with your users in mind. So not just someone who knows exactly how to use the library with no bugs, but to keep in mind the people that are going to be writing bugs in the code that you write. I'm sorry, it's reality. If people are using your code, they will use it to write bugs, even if your code itself doesn't have any bugs. And so you need to make it accessible for people to actually use tooling with the code you're writing. This talk is mostly how to get started. So I am talking about advocacy in the bookends of this talk, but a lot of this talk is the how to do this in Visual Studio NatViz and how to do this with GDB Pretty Printers. Basically, how do I get started? And I'm hoping between Visual Studio NatViz and GDB Pretty Printers, that kind of encompasses everyone in this room. Does anyone in this room not use the Visual Studio debugger or GDB? Is there another debugger? Okay. Okay, so it is a few people, but I'll say I addressed most of the people in the room, and I'll consider that a success. There's not much C++ code in this talk, but there's, C++ ecosystem type stuff, and please questions at any time. I love the interaction. And then just before I get into it, a little bit about myself. I'm Canadian. I have a mechanical engineering degree. I like twisty puzzles, as I talked about in my lightning talk yesterday. I'm on the C++ Standards Committee as of a couple years ago. I run the Winnipeg C++ Developers Meetup Group, which actually is a spin-off of CPP Toronto, which runs CppNorth. So actually, I run a sister event to this current event. Kind of cool. We meet about once a month. So if anyone here is from Winnipeg that I don't already know about, then please come to my meetup. Next one is, actually it doesn't matter, this is getting recorded. Okay, and I'm also the volunteer coordinator at this conference. So if you see me around, just running around and doing things, that's why. Okay, let's talk about setting up NatViz. I will ask before I get started, has anyone here written any NatViz before? Okay, there's a couple people. All right, by the end of this, hopefully you'll all know how to write NatViz. A NatViz file is XML, and it's a .natvis file extension. It stands for Natural Visualization. It is a plugin into the Visual Studio Debugger, and here's what it looks like. There's nothing here, but this is the most basic NatViz you can write. It has an auto visualizer tag, and it just, points to the schema, and that's kind of it. Inside of the auto visualizer, you have a bunch of type tags. So this one will match against my class, and then this one will match against my class template of star. Now, notice less than and greater than are escaped. This is XML. So I'll talk about setting up in Visual Studio and in CMake. I also assume that encompasses the majority of people here who do use MSVC. So in Visual Studio, you take your project, you right-click on the project, you see this, add, you go into new item if you actually want to create a new one. If you already have one, you can add the existing item, but you'll want to add the new item. Once you get to this window, you click Utility, and then you go to Debugger Visualization File, .natviz, you create it, and it exists. And it's in your project, and you get to use it immediately. So that's pretty nice, quite easy. It's also very easy in CMake. You just need to add it as a source to your target, either in the add executable or add library call, or you can do it later in a target sources call. For those of you in the room that don't know CMake, don't worry about it. For those of you in the room that do know CMake, you will know that this is dead simple CMake, as simple as it gets. And this is really all you need. So it's very simple to set up NatViz. And the results are very nice. Let's say I create a line. It has an int left and an int right. I'm imagining like a line on the number line. And then I create this line, I create an object of type line that has 100, 600. Without any NatViz, this is how it displays. So it shows brace left equals 100, right equals 600, and then it shows the left and the right. And in this case, that's fine. But maybe it isn't. Maybe I want to write something a and I want it to look, a little different from this. So I write some NatViz. Don't worry about this for now. You'll understand this later. So I write a little bit of NatViz, and then it ends up displaying like this. And this is what I want it to look like. I want the line, the actual display value of the line itself, to just say 100, 600 in some braces, and then I want to have one item underneath that. I want it to say length. Raw view is just an auto-generated sort of thing inside everything that you write NatViz for. It's just, what would the type look like if there was no NatViz on it? And you can see that actually matches up with what's right above it. Okay, let's write some NatViz. So I showed the NatViz type tags here at a high level. We're going to zoom into this and specifically into these triple dots. And I'll do it in 4 sections. I'll talk about the alternative type tag. I'll talk about the attributes on type. I'll talk about the display string tag. We'll talk about some expansions. And then we'll talk about the intrinsic tag. So importantly, we can access any data members no matter the access specifiers. Because we're in the debugger, we're just looking at the data. And if you have the symbols, you have the symbols of even the private things, because that's just how the compilers and tools work. So you can access any data member, but you cannot access any functions. You cannot call into any user-defined C++ functions in the Visual Studio Debugger. You actually can call into, I think, C# functions in the VS Debugger, but not C++ functions. So, and this is, a C++ talk. There are some NatViz features that are not documented. I think there are 1 or 2 that I'm going to mention in this talk. And this presentation is not exhaustive. But if you want to talk with me more about this, I would love to. I love this stuff. So the alternative type tag, this is where we'll get started. You can put something into the type. This is from stl.natviz, which is the file that is preloaded into Visual Studio to display everything from the standard library. This is open source. This is on GitHub. It's on Microsoft STL. So I have the type tag, which has a name, stood unordered map of star. And then I have alternative type, which is unordered multimap, unordered set, and unordered multiset. And this just exists here basically to specify multiple names. That's all we're really doing. We're specifying multiple names for this type, and that's it. There are some interesting attributes. One is inheritable. So if we have a class B and then we have another class D that inherits from B, if we create a visualizer on B and then create an object of type D, it will not use this visualizer. Why? Because it has inheritable false. If you gave it inheritable true, or you just left it out, then it will automatically inherit. So you create an object of type D, and it will use this visualizer, but this gives you sort of granular control. Include view and exclude view are interesting and applicable in certain cases. Include view foo here means that we are only going to use this visualization when we are using the foo view. And exclude view bar means we can match against this visualization for every view except bar, including using no view at all. What is a view? Has anyone used views in the VS Debugger before? A few hands. So in the Visual Studio Debugger, so in the watch window, for example, you can type my class, that's the name of my variable, and it will display as whatever it displays. But you can also write my class, comma, view of, and then something you want to put in there. So here I have comma, view, foo. And this exists. This is a feature, it's documented. And it's there. So basically, the first line there, view foo, will actually match against both of these visualizations. And the bottom one, view bar, will actually match against neither of these visualizations. And that's not quite helpful. We want to prioritize them. So there's a priority attribute. And you can specify priority medium, medium high. There's a few others, I think medium low, low and high, I think. And typically the ones that I see are medium and medium high. So what will happen is, if we try to match against a visualizer of any of these visualizations, we will try to match against the bottom one first, and if that fails for some reason, then it will try the top one. But it does try the bottom one first, and so this is how you specify an ordering. Now these are actually used together quite well in stl.natviz. So the stood unordered map has priority medium, but then there's another one for stood unordered map with priority medium high, but it has an exclude view, which means always match the bottom one unless we have that view, in which case match the top one. And so this is used in certain cases for displaying the index because displays with the hash tables are different when you want maps or sets, and so this is the way that they work around it. The display string tag is a format string. It looks like a Python F string, and it is the first thing that you see in the top line of the Visual Studio Debugger when you output your type. So here, it looks exactly like an F string. Has anyone in this room not heard of Python F strings? 0 people. Awesome. So, okay, so this is how the point will display. If you don't expand the arrow, it'll display as x equals 3, y equals 5, assuming I have x and y as 3 and 5 respectively. So quite simple here. It can get a little bit more complicated with the condition attribute, for example. So this is stood optional, again from stl.natviz. Stood optional has 2 variables. It has value and value. If has value is false, then this display string will display null opt, as in the literal null opt. If has value is true, then it will actually display the value. Now, how does it know what to display? Well, it goes recursively and checks if there's any natviz on that type itself. If there is, it uses that. If there is not, then it uses whatever's built into the Visual Studio Debugger to display a non-natviz type. There are 2 display strings here. You can only have one, but actually you can only have one active one. So it's fine to have 2 as long as, up to 1 is active at any given time. So given the conditions, you're fine. You can do this kind of complicated stuff. Okay. And that actually means based on the runtime value of your type, you can display your type a lot differently. I have a question over here.
Yeah, is that Boolean, is that defined in the type you're trying to...
So the question was, is that Boolean defined in the type? Yeah, it is. So that's one of the data members of stood optional. It's not mandated by the standard. It is, in the Microsoft implementation of stood optional, that's what the Boolean variable is. Stood optional is typically implemented as some data and then a flag to see whether it's set or not, and that's the set flag, basically. Yeah, so in here, it's an expression in quotes that you're able to access data members through. Basic expansions I'll be talking about. I won't talk about complicated expansions, but I'll talk about some basic ones. So there is a thing called item here inside this expand tag, and here's what it looks like when we display it. So the item has a name of length, and it has an expression of right minus left. Now right evaluates to 600, left evaluates to 100, so right minus left evaluates to 500. And then it displays in the debugger as length 500 with the square brackets. It doesn't have to have square brackets. I can add some dummies and some other dummies. So there's the dummy of 1, 2, 3, just a dummy value of 1, 2, 3 there, and that's how it displays, and it's an expression. Or, I can use any of the data members. So I have this left data member, 456 plus left, makes 556, and I surrounded the phrase other dummy with some parentheses. You can do anything you want, and in fact the name is a format string, but I'll get to that later. Now, here's the thing. I don't want that raw view there, but there's no documentation to say that I can get rid of it. But I can. You can just hide raw view. And it's interesting, this isn't documented. I found out about this recently, and it's very nice to see, because sometimes in a simple class, I just don't want that there. I would advise that in a complicated class like a container that's used for mass appeal, I would not advise hiding the raw view, just because it's buried at the bottom anyway, and just in case someone needs to use it, then they have to go modify your navviz, and that's not really nice. So I would not keep it. Yeah, or I would keep it.
But if you add a new member to your class, will it show under a new raw view, or you have to implement?
But if you add a new member, will it show under the raw view? Yeah, it will. So the raw view is basically how would your type display if there was no navviz on it. Okay. So I'm going to expand this item tag, and I'll show off a few attributes. You've already seen conditions, so here's the condition on the item. I just want this item to only display if right minus left is greater than or equal to 0. Again, I have to escape the greater than because it's XML. So if right minus left is greater than or equal to 0, then I want this length to display. If I have a negative length, I don't want to display it. I have include view, detailed, semicolon, advanced, so this only displays when I have detailed or advanced. Alternatively, I have exclude view, so I display this length always unless the person specifies simple. So that all works. Let's talk about some more advanced expansions. So imagine you have std array, and std array has obviously two template parameters, and we know the size of the array at compile time, so we can output that in the display string. But what does our expansion look like? How do we iterate over a pointer and a size and then output all of the items of an array? There's a thing for that. Array items. You just specify the size and you specify the value pointer, and it knows how to go through that pointer and just iterate until it hits size number of items, and it just outputs them. And I'll show you what that looks like. So here, if I create a std array of 2 lines, one of them is 100 and 600, the other one's 2 and 5. Here's how it displays in the Visual Studio Debugger. Lines, size equals 2, that's the display string. Then I expand it, and I see, I have 0 and 1. 0 is 100, 600. 1 is 2, 5. You might recognize those formats as the display string we wrote previously, so that's nice. And I can expand those, and I can see the lengths. And you also might recognize that. So, it just works. It works recursively. Array items just works. There are a few other automatic expansions that I will name here, but I won't go into them. There's index list items, which is basically if you have an index and some sort of formula by which you can get the object at that index, then this might be for you. If you have a linked list, you may want to be using this. You can expand linked list structures. Basically, if you have a starting pointer, and if you have a formula to get from any pointer to the next pointer, basically doing mathematical induction here in Visual Studio NatViz, then you can do this. And then tree items is for specific shapes of trees. I think the ones that only have a left and a right, so any sort of tree with 3 items won't really work in this in this situation. But if you have a tree that only has a left pointer and a right pointer, then this will work. You specify a left side, you specify a right side, you specify a start, and it just works. So that's pretty nice. Expanded item is pretty cool because you can take basically a child and you can take its contents into the parent. So imagine I have a line wrapper that holds a line, and now I'm creating a NatViz for it. And what I do is, well, let's create the display string. Let's defer to line, and this defers to line's display string recursively. And then I have an expanded item. And the expanded item for line basically means, hey, let's take everything from the inside of line, stick it up into the parent of line wrapper, so we don't even know that line itself exists, we just take all of its items. So now when I create a line and a line wrapper, this is what I get. Notice that they are exactly the same, except there's a raw view on LW. And the reason there's a raw view is because I didn't tell it not to. Otherwise, they are identical. So they have the same items, and if I updated lines natviz, then the natviz for LW will just automatically, it automatically works no matter what I specify for line. There's an opposite of that. There's synthetic, which is where you take some things and put it into an artificial child. So here I have the previous natviz for line. I create a line of 100, 600, and this is how it gets displayed, and let's walk through how this goes. We create a synthetic named calculated, and I want to stick all of the calculated things inside of it. Synthetic is interesting because it's not a normal item, it is an entire type. So it has its own display string, and this time it says line properties. And it also has its own expansion, so I can put in this expansion and say I want an item called length. But look, I can actually collapse it. I can visually collapse it with an arrow in the Visual Studio Debugger, and this is pretty nice, just in case I have a bunch of calculated properties, or I have some properties that I want to categorize into different ways that I want it to be easy for the user to collapse and expand specific sections. You can do that. That's what synthetic is for. Let's create another one. Let's do a midpoint. Some stuff you might want on lines. Now, you may think, I have a type at work or at home on a hobby project that none of this stuff would work for. That's okay, we have custom list items. It's not my thing, I'm just talking about it. But custom list items is a manual expansion, effectively. You create variables, you execute statements, you have branches and loops, and then you output the items. It's effectively a domain-specific language to iterate over your structure. And let me show you how that looks. I have the same visualization for line, but this time I have a custom list items down here. So, this is what it looks like for now, assuming the custom list items is empty or non-existent. Let's expand it out and let's add some stuff in here. Inside of custom list items, it is kind of like a programming language. So anyone who says that XML is not a programming language has not written natviz. So let's create a variable. This variable is called steps, and it has an initial value of 5. And that's because my goal here is to start from the left side and then have 5 evenly spaced points to the right side. The step size is going to be the length divided by the number of steps minus 1. As in, to get from 100 to 600, well, I need to get a quarter of the way there so that I can get 1/5 of the elements, basically. The current value, it starts at left, and then the index starts at 0. So now, let's do some logic. Let's create a loop. We execute ++ index. Yes, this does have a side effect, in fact. And then we can execute current equals left plus index times step size. And in doing that, we have calculated the new current. If the current is greater than the right, let's break out of this loop, and that's our custom list items. But I also want to output the items, so let's do it here. We have just whatever the current is at that point, we want to output it. I don't specify a name, and therefore it just outputs as 0, 1, 2, 3, 4. Perfect. What's the behavior of Visual Studio if there is an infinite loop? I actually can't remember. It either freezes or it fails. It's something. It doesn't like have demons up your nose or whatever the phrase is, but it does. It doesn't work. So you do have to be careful to not have infinite loops in custom list items. So I output these items here. Let's say I want to clean up the code a little bit. I don't actually have to do if condition then break. I can just do break condition. And then I also can put this condition inside of the loop itself as long as I flip it. So instead of greater than, it's less than or equal to, and I stick it in here. And let's collapse it down a little bit. I have some empty space. Now I realize, I look at this and I say, between the length and all the items, I want to show the steps. How many steps are there? Yeah, right now it's a constant, I understand, but maybe at some point it won't be, so I want to display this here. So I'll do that. I'll display the steps is 5. Does anyone notice something wrong with the visualization now? Index, we started at 1, and obviously that's incorrect, so we have to fix that. We have to go into the item and we have to give it a name. I said previously that you can give a name with a format string, and so I just do that. I use square brackets and then I pass the index and it just works. So now I have 0, 1, 2, 3, 4, for regardless of how many other items that I add into this custom list items. So, great. I'm going to talk about intrinsics. This is the last part of natviz. I'll talk about user-defined functions within natviz. They are a member function if they're defined within the type tag, and they're a free function if they're defined outside of the type tag, just in the global, auto visualizer tag. And you can do that. They can have parameters, they can be overloaded. I won't show either of those things, but I would love to talk about that in a subsequent talk. So if you look here, you might see some duplication, and I don't like duplication. I am a programmer. I'm sure a lot of you in the audience will agree with that. I see right minus left, and I just don't want it. I don't want that. There are 3 times I write that. So let's instead write an intrinsic, and it's going to have a name length because that's the most sensical name for it to have. And then it has an expression of right minus left. Now, there's no body to this intrinsic tag. If there was, I would put parameters in there. There are no parameters, so I don't need a body. The expression is an attribute. So the name is length, the expression is right minus left. This is a function. You can call it. So instead of doing right minus left, I will write length paren, and that's about as simple as I can make this now. So that's what intrinsics are for. That's just the basic. That's just a basic intrinsic that you can use inside your type. Now it does get a lot more complicated from there. There are some official docs. You can create custom views of C++ objects in the debugger using the NatVis framework. This is the official documentation for NatVis. This is most of what I use to learn what I know. There is also this article. Don't take a picture yet. Hold on. I'm progressively revealing. Maybe I should do all of it. So here, there's a new article called Implement NatVis Custom Intrinsic Function for C++. This is new as of January 2025. I didn't actually read this article until writing this talk because I didn't know it existed. It's a great article. If you want to know about intrinsic functions, this is a great place to go. I also have my own articles that I wrote. I wrote NatVis for Boost Unordered Map and how to use intrinsic elements at this link. I wrote NatVis for Boost Concurrent Flat Map and why fancy pointers are hard at this link, almost the same URL and almost the same title, I guess. And then I wrote, I want to write automated NatVis testing at this link here. You might notice the title of the bottom one sounds quite interesting, and it's because, of course, I failed to do that. But hopefully one day, we'll see what happens. For a subsequent talk, I would love to talk about the optional attribute, which allows for kind of Sphene-like features within NatVis. It's quite powerful. I'd like to talk about advanced intrinsics. I'd like to talk about writing NatVis to allow user-injected behavior. I'd like to talk about that automated testing of NatVis that I mentioned, and of course, I have a wish list for what I wish was in NatVis, so I would love to talk about this kind of stuff in the future, but we're not there yet. For now, I have to get to GDB for the other part of the room that uses GDB. Who here has written a GDB pretty printer before? Okay, a few people. Cool. So this will not be new for you. A pretty printer setup is, I would say, harder than the NatVis setup, but I would say writing a pretty printer is easier. So I'll go through the setup. It'll take a little bit longer. I'm going to talk about some basic GDB for those here that have never used GDB before. I found it quite complicated the first time I used it, so I just want to go through this. I'll talk about the GDB init file, which allows for automation. I'll talk about linking custom pretty printers, and then the plumbing that you need to get there. Basic GDB. Here's the most C++ you'll see in this talk. I have x is 5, y is 6, and then z is x plus y. Obviously z is 11, but I don't know that myself. I want to find that out in the debugger. So I compile main.cpp with clang, and then I run GDB. Inside of GDB, it does all this stuff at the beginning, and then I write file a.out. And what that means is, well, I didn't specify the name of my executable, so by default it's a.out. So I write file a.out. The file command loads in your executable, so it loads the symbols. Alas, I have no symbols. Let's start from the beginning. Now, let's compile with -g, and that means let's add symbols. Perfect. Now I run GDB. File a.out, reading symbols from a.out, that's a success. Okay, let's ride that wave. Let's keep going. We're still in the same session of GDB. I want to start. Start will create a temporary breakpoint at the beginning of the program, right here, and it's on line 2. So it'll be int x equals 5, that's the line that we're at right now. I don't want to be at that line, I want to go next. Now I'm at this line, line 3, and I want to go next again, and now I'm at this line, line 4. Let's print out what z equals. So z equals 0. Okay. That's wrong because we are at the line. We have not yet executed the line. So let's go next again, and now we are at the closing brace. But we haven't executed the closing brace, so we're still inside the function. And so let's print z, and we get 11. Hey, That's great, success. The problem is I don't want to start next until I get to where I want to go. I want to do that with a breakpoint. So with the Visual Studio Debugger, clicking a breakpoint in the IDE is quite easy. Doing it with GDB, you don't really have an IDE. I will mention VS Code later, but there's no native IDE for GDB. So after loading the file, I'm just going to break at line 5. It's a lot simpler, and instead of start, I'm going to run, and it goes to the breakpoint. I'm at that closing brace. It's a lot simpler. I can print Z. It's 11. But realistically, if I'm debugging, this is too much to type every single session of GDB. Let's get into GDB init files. So this is my C++. Here is a file called GDB init. Excuse me, it is in the same directory, and everything is just in one small flat directory. So inside of this .gdb init file, I put the commands that I want GDB to run once I start it up. So I have file a.out, I have break 5, and then I have run. All of the things that I want to do. And I want to do this every time because I'm in a debugging loop. So I don't want any friction between restarting the cycle. So I run GDB, and it has an error. Okay, so actually this didn't work. Auto-loading has been declined by your auto-load safe path. Anyway, it tells you exactly what to do. If you read these instructions, it's a lot of text here, but if you do read these instructions, it will tell you to go to this file, /home/Braden. I don't know why any of you have a Braden directory, but that's okay. /.config/gdb/gdb init. That is the name of the file. Note there's no dot by gdb init. And then all I have to do is add autoload safe path to wherever my GDB init file is. And now it should work. Okay, cool. I'm crossing my fingers as if this is like a compiler or anything. And then I print Z and I'm at 11. So there we are. All I did was I started GDB and I'm exactly at the point where I want to. The executable is loaded. I'm at the breakpoint. I have run up to that point and we're good. So it just makes automating things a lot easier. Let's link in some custom pretty printers. So I'll show a very basic pretty printer here. Actually, I guess this is more C++ code than the C++ code I showed before. So I have class myType, and then I have int main, class myType, int main. Inside of main, I have a myType that I created. So I'm sure everyone here has written code that looks like this before. Here is a pretty printer. This is the most basic pretty printer that you can make. You have a class. You have your constructor. Your constructor does nothing. And then you have a toString function which returns some sort of string. Okay. I'm assuming everyone in the room is at least somewhat familiar with Python, given that it's kind of a lingua franca of scripting these days. Does anyone have a problem with this code here? Cool. Just making sure. I'm going to add a few things to GDB init. I will set pretty print on. This is a global setting. You only need to do it one time, but I like doing it in GDB init because then I just ensure that it happens every time. It doesn't really take up any extra resources, so I would much rather do that. And then we have the source command. And the source command is what actually loads in the pretty printer. So source mytypeprinter.py, that's the file that I have at the bottom left. And so now once I've done that, I run GDB. I'm at the breakpoint. I print mytype, and it prints. Hey, we just wrote our first pretty printer. But the problem is, at the bottom left, I have an etc for the plumbing. So let's call the plumber. We need to import gdb.printing at the top of our pretty printer file. When I say have to, it's kind of loose. In certain cases, this will be fine if you don't import it. In other cases, it won't. I've ran into both. I just do it just to be safe. The nice thing, though, is because it's Python, I misspoke. The nice thing is that you don't have to use pip or any sort of package management to install this. GDB's internal Python already has this. So you don't have to worry about where does this come from. In fact, when I was first learning how to write pretty printers, I really got hung up on that. I didn't want to get started because I first thought, well, no, before importing a package, I need to know where the package comes from. No, it's there. It's already there. It's inside GDB. I have the pretty printer that I just wrote. And then I create this function, build pretty printer. I think this is typically the way people do it. This is the common thing. You create a regexp collection pretty printer. I'm going to name it my printers. And then to this pp, I'm going to add a printer. So I'll add a printer called myType, and it will match against a regular expression that matches the beginning of the string, and then myType, and then the end of the string, just making sure that that is exactly the type that I match. And I'll give it myPrinter. Because we're in Python, obviously we just pass classes as runtime arguments. I add another printer. This one is called myTemplateType, and it matches a templated type. Now the template type that it matches, of course, again, this is a regular expression, so you have the caret, myTemplateType, and then the angle brackets with dot star, and then $, and you're good. It just matches anything that matches that regex, and again, I pass it that same printer. Note, I can use the same printer multiple times. This is actually kind of similar to, in NatViz, an alternative type tag, where you can use the same printer for different types. You can do that here too. Notice this printer does nothing at all, so it can be registered for any type you want. You could register this for caret dot star $, which would mean that it would match literally everything. Probably a bad idea, but hey, maybe. And from this function, finally, I just return that collection. And then finally, at the bottom of the file, note this is all just one file. I have the breaks in here so I can gradually reveal. You register the pretty printer. 2 arguments. First one's the current object file, and then the second one is build pretty printer, that function you just wrote. And with that, we have plumbed our entire pretty printer. So let's write some GDB pretty printers. It's Python, as I mentioned. And because it's Python, we get the full power of a programming language. We can get external libraries in our GDB pretty printers. So it is quite nice. I do find it easier to write than NatViz. That is just my opinion. Some people may find NatViz easier to write. I find GDB easier to write for, I would say, 2 particular reasons. One of them is that it's Python, and Python is very easy, and it's quite ubiquitous. The other one being that it is just a programming language at all, whereas NatViz is not a programming language. Now, of course, they are used for different tools. I'm not comparing that one is better than the other. I am showing them both off here. I'm just, expressing my opinion on which I like more to write. So here's how to write a GDB pretty printer. We'll talk about constructors and the toString method. We'll talk about the children method. And then we'll talk about using GDB from VS Code, which is where GDB turns from a command line interface into a GUI. But we'll get there. So this is what we have so far. I have a struct called line. You may remember this from previously. We have int left and int right. I'm going to change the stuff on the left so that it works with line. I'll just rename everything. I now have line printer. The add printer call is to line. Great. And now we throw all that out the window. We don't have to worry about that anymore. It's just there. If at any point you need to register another thing, you just go back into that function. You register another printer, but otherwise you shouldn't really need to touch any of that stuff. So in this line printer, you have a constructor and you have a toString. Let's start with this constructor. What is val? Val is the object that you have, or rather, it's a handle to the object that you have inside the debugger. So we should probably store it inside the class. Do self.val equals val. Obviously, it doesn't have to be named val. That's just convention. The toString function is also quite simple, I would say. We take in the self, and because of that, we can access self.val. And so, let's do that. Let's grab the left data member. Now, grabbing the left data member, it uses the dictionary syntax in Python. And you can just chain these if you have nested members inside members. Then I'll store right as self.val quotes right. And then I'll just return an f string. You may remember f strings from earlier in this talk, and it's just about the same f string as before. This time it's actually an f string though. And so then, here's what it looks like. If I have a line that is 100, 600, I'm in GDB, I print the line, and it works. Cool. Okay, so we just wrote a non-trivial pretty printer that actually relies on the runtime data inside of the object. I think that's pretty great. Now, the children method. So it must return a Python iterator, and each item returned from the iterator is a name-value pair. So it has to use the iterator protocol. There are different ways of doing this. I'm just going to show one of them. So the way that I prefer to do this, and note I'm actually changing the toString method to just return line of length, length. The way that I prefer to do this is with a generator. I just use yield. I think that's the easiest way to do it. I'm sure there's some stuff in itertools that you could use. I'm not too familiar with that stuff. I'll just roll it myself. And so What I typically want to do is I will have a children function that has a generator function inside of it. Then at the bottom of this function, I just return calling the generator. And now once I do that, GDB is able to take that and it's able to iterate over it and just grab all the name value pairs. So what does this look like? I'm going to make it look quite a lot like it did in NatVis. First, I need to grab the left and the right. Now, I could have stored these in the constructor, because you note, I'm calling them inside children, and I'm calling them inside toString. So potentially we could save a few cycles if we cache them in the constructor instead. I didn't do that here, but maybe that's advised depending your use case. I'll initialize these same variables that I did in NatVis, the step size, the current, and the index. Now we're in an actual programming language, so we're able to iterate over it properly. Before doing that, I'm going to yield the steps. So as I said, it's name value pairs. So I want it to output the word steps, and the value that I want it to have is steps. While current is less than or equal to right, it's very nice I don't have to escape that anymore. I just yield a name value pair of an f string, comma, whatever the current value is. Then I increment the index, and I move the current to the next position, and we're done. And that's our generator. So we just wrote a generator in Python. It implements, of course, the iterator protocol, and so we're able to use it in GDB. Now, I do want to have a quick side note, and note that left and right are not ints. The type of left and right are not ints. They are gdb.value types, which are handles into the data inside of the debugger. However, in Python, they do have overloaded operators depending on what type they are. And so I can say step size equals right minus left divided by steps minus 1. Well, right is not an int, and left is not an int. And right minus left is not an int, because it's still a gdb.value, and therefore step size is also a gdb.value. So just keep that in mind. I don't have enough time to talk about all of that kind of API stuff today, but I do just want to note that if you end up writing these and you are confused about what these values are doing, they are not the type that you think they are. They are a handle to that type in C++. So does it work? Let's create a line, 100, 600, and yeah, hey, it works. There are different ways that you can format this when you have a print call. That's one of the advantages to using children instead of just formatting your own string. Because realistically, this is a command line interface. It's just a string here. I could have just output all of this from toString. I don't need a children function to do iteration, right? I could do iteration in toString. It's a programming language. I can do any of that. The advantage is GDB can cut you off if you have too many items. You can, max it out at 50. It could display in different formats. Using children actually allows that kind of stuff to propagate through. If you don't use children, none of that propagates through, or you could propagate it yourself. It's complicated. I've tried. It's not worth it. Use children. If you have any items that you want to display as children of your actual item, I just don't do anything else. I want to talk about using GDB from VS Code, because this is how I personally use GDB these days. It takes advantage of VS Code's GUI. You cannot use a GDB init file, or at least I was not able to figure out how, and it was quite a frustration, in fact, writing this talk when I realized that it didn't work using a GDB init file. So if you're going to use a GDB init file, you must use it from the command line. Otherwise, you're going to have to actually specify commands to VS Code itself. Now, it does require GDB 14.1, otherwise toString is broken. If you have any GDB earlier than that, the toString, the display, is just not going to show up properly. Here's the Bugzilla for it. I went hunting. Okay, so here is a launch.json file. Does anyone here not know what a VS Code launch.json file is? Hands? Okay, yeah, okay, I see a few hands. That's fine. I was actually hoping, because then my explanation is not in vain. So this is what tells VS Code what to do when you're in a run and debug situation. This is what it defers to in order to actually execute this kind of stuff. So these are auto-generated. If you want it to be, you can actually just auto-generate it, which is how I make mine, which is why I'm not showing the rest of this. Inside of configurations, there are a bunch of things. One of them is setup commands. The way that you generate it is you click Run and Debug in Visual Studio. If you don't see the thing that is on the right-hand side of this image, you might see create launch.json, and then you click that, and then there will be a menu, and then you can choose exactly what you want it for. You select the GDB option, and it just generates it for you. It's actually really nice, and it makes it so that I don't have to explain it in this talk, which is great. Once you actually do have it set up properly, you have to give the launch.json the name of the executable, or sorry, the path to the executable, the path to GDB. Once you have all that set up, you can actually click Run. The name of my executable is CppNorth 2025, but it is cut off because slideware. I click Start Debugging, and it does this. So it's a GUI. I set a breakpoint on line 8. I click that with my mouse, and I have a breakpoint. And I'm using it visually with GDB, a famously command line interface. I think that's nice, and it makes it a lot more usable to me, who is a lot more familiar with using GUIs. So I think this is great. And again, it just makes this kind of thing more accessible to, I would say, people like me. There are, of course, the buttons as well. I guess I'll use my laser pointer for the room, but I guess that won't show. I'll use my mouse. Right here. Okay, cool, because capture. So right here, you can click all these buttons. That is continue, next, into, or step in, step out, restart, stop, all of these things. It's nice. You don't have to use any sort of command line. And if you look on the left-hand side, the line is displayed as triple dot, and then it has children of left and right. This is not using a pretty printer. So let's add the pretty printer. Inside setup commands, which of course is one of the things inside a single configuration, but inside setup commands, this command should be auto-generated. It's just -enable pretty printing. This will be auto-generated, at least in the version of VS Code that I'm using. Works on my machine. This is what you need to add. And if you want to do any sort of thing that would be like a GDB init file, here is where you do it. It's inside setup commands. You just add more of these entries to this array, and text is actually the command that it sends. So in this case, I'm sending the source command. And source was how I loaded a pretty printer. And so look, hey, I'm loading a pretty printer. I just do it at wherever the workspace folder is, /lineprinter.py, and the results are, oh, it prints. Hey, look at that. On the left-hand side, the display, the toString, says line of length 500, and then the children show up as children, right? If we had just written this entire formatted string inside toString, it wouldn't show up like this. But because we actually wrote it in the principled GDB way with children, then we're able to do it. It's able to show up as the actual children with a collapsible line. It's able to be readable. Again, your users are able to actually use this properly, which I think is really nice. And this is the kind of stuff I use at work. This is, I mean, obviously I don't write this code, but this is the kind of stuff that I use, just to make my developer experience a lot better. And I want that to be the case for all of you as well. So here are the 2 resources I'm going to list. I'll just expand them all. There's Python API, which is at the official GDB documentation. It is a very good read. I have read through probably most of it at this point. And then I have an article called Visualizing Boost Unordered Map in GDB with Pretty Printer Customization Points, which goes into some more detail of some complicated Pretty Printer stuff that I did. There's a subsequent talk that I would love to give. Along with my subsequent NatVis talk, I want to give a subsequent GDB talk. I want to talk about GDB.value and GDB.type. I want to talk about writing pretty printers to allow for user-injected behavior, which is something I did in Boost. I want to talk about X methods. This is a way of doing, of adding basically member functions on your type that are callable from within GDB, but not from within the pretty printer. They're callable from a user perspective. So you're able to end up basically outputting another pretty printer by calling an actual method on your type. Very interesting. Obviously, I can't get too much into it now, but it's very good. And I want to talk about embedding pretty printers in the binary. And again, this is what was done in Boost Unordered, is that if you have included Boost Unordered Map, and if you haven't touched anything else, and if you're compiling for Linux to an ELF, the pretty printer is in your binary. You don't actually even have to know anything about where the pretty printer is in the library. You don't have to include it yourself. It actually is already there, which is pretty interesting. And that's the case today. If you're using it today, that will actually work with Boost Unordered. So I'm pretty happy with that. I worked with Niall Douglas to get that done, if any of you know who that is. And it was cool to do. So I would love to talk about that in the future. So, in conclusion, please write visualizers. And now you know how. Aha, see, I caught you. You're all in here, and maybe you're thinking, maybe I don't write visualizers because it's too hard, I'm not sure how. I walked you through step by step. You have to do it now. It's accessible. It's accessible to you. I am helping to make these tools more accessible to you, so you can make the tools that you write more accessible to the users that you have. I think your colleagues will thank you. I think your future self will thank you. And I don't even want to put it up, I need to say it. Your users will thank you. Let's say I'm a user of your library, I will thank you. It's just, I just think this kind of stuff is very important. Because ultimately, I want developers to feel empowered. I want people to feel like they know how to use the tools at hand properly, and that they don't have to patch the libraries that other people are writing in order for them to get the tasks done that they need to get done. I just feel like developers need to feel empowered and not discouraged, as I have felt many times throughout the process of learning all these sorts of things. Yeah, I just want people to feel good about it. I want barriers to understanding to be removed. I just want people who are new to programming or less experienced in certain areas to be able to get those quick wins so they can just continue on and, I don't know, become the developer that I know they absolutely can be. I want libraries that are more accessible to use. And hopefully I'm setting an example here. Widely consumed libraries, I want them to have debugger support. So, these are the two main debuggers that I'm talking about. Maybe in the future I'll talk about some more. But I say that our work is about a lot more than just the source code. Our work is really about the people, as we've heard about throughout this conference. So, as this conference comes to a close very soon, I just want to say, let's make our code accessible. Thank you so much. If there are any further questions, I would love to take. Otherwise, I would love to... Okay, I'll answer that question. Sure.
I tried to use NetWiz on Visual Studio on Windows for a subsystem for Linux. It did not work for me. Any special should be done?
Were you using MSVC on Linux?
Yes. Yes.
I didn't know you could use MSVC on Linux. I'm sorry, I actually don't know.
Oh, you can. You can run from Visual Studio Linux servers and programs and debug on Visual Studio.
Is that within Visual Studio Code or within...
No, Visual Studio, yes.
Oh, that is news to me. I'm sorry.
And NetWiz doesn't work in this case. I did not succeed to make it work.
I don't know. Yeah. I mean, if you are using MSVC, I'm sure there must be a way, but I can't say that I have any experience doing that. I do have experience using WSL with VS Code, and then you can get... And that's what I showed with the GDB. I'll actually go back a few slides. That's what I showed too far back. Wow, I'm surprised. So this is using WSL here, but I didn't know you could use actual Visual Studio with WSL, so that's news to me. Maybe I'll look into that. Any other questions? Yeah.
If you're an Emacs user, you can also get that graphical GDB experience with MetaX GDB.
Okay, noted.
Hello, Braden. Good talk, thank you. Do you have recommendations? Because I won't write a navigation NetViz file for every one of my types. Do you have recommendations on which one should I pick my...
Yeah, whatever you think is used by the most people, basically, in some metrics. So whether that is, used by the most people in general, or used by the most members of the public, or used by the most people that are less experienced, maybe. I don't know. I mean, just by some metric, whatever you think it would have the biggest impact on is where I would say you just start.
Let me maybe rephrase, because a line example with 2 ints is pretty simple.
Yes.
Is there a pattern in a class, like a bucket inside of an unordered map that you want to see inside? I see the value to put it. Is there a pattern in a class, like as soon as there is a pointer to something else, then it's useful? Sorry,
okay, yes, I understand. Containers, I would say, in that case. Because typically, containers aren't just directly visualizable in a debugger without any debugger extension, right? Because they're usually pretty complicated, either for efficiency or for memory purposes or whatever. they're typically pretty complicated. You want to have a debugger for that. So my answer is containers. Yes.
So you showed the .gdb init file. Where do you place that in your repo? Do you commit this to Git?
I typically don't. I put the gdb init file wherever I am running the gdb command from. And I just... I think there are more complicated ways of using it. I don't use it in those ways. Like you can put it in your home directory and it looks there first. But I don't do that. I just write it every time.
So if there are there's a team working, or if there's like a big organization working on this project, each person would need to write their own GDB init file to get this kind of developer experience.
Yeah, but I think typically that makes more sense to write your own GDB init file, only because I have never, maybe you have, I've never debugged something along with somebody else. Like I've never done pair debugging, or I've never done debugging long enough that I have to check in my process for debugging this particular problem. Because that's what GDB init is for. It's for running a bunch of commands in GDB right at the initialization, or at the startup of GDB.
Right, but I'm thinking of a case where you got your wish. And, this massive project that we work on that has, thousands and thousands of classes, has all, maybe hundreds and hundreds of GDB pretty printers.
Yeah.
And then some new developer joins the team.
Yeah.
And will they need to kind of manually add all these different files
so
and so
how
on?
will they, right, so you're asking, how will they include all of those pretty printers into their session without rewriting that source this one, right?
Yes, also when a new pretty printer is added, all the team members don't need to manually add them to their GDB init file.
So I would say, if you're writing a pretty printer for a type, you should, and I didn't show it in this talk, but you should have it automatically embedded itself into the binary, which is what is currently the case in Boost Unordered. If you use Boost Unordered map from Boost 1.87 or later, I think, then it's automatically in your executable. So it's just already there. And that just makes things easier so people don't have to worry about it.
Thank you.
Yeah, thanks. But I should talk about that more in the future, because that's an important point.
Yeah, I was just going to say, did I blink? As a library author, how do I get my pretty printer into your executable?
Yeah. So, I guess, no,
I didn't blink.
Yeah, no, I didn't explain that. I mean, for me to get it into my executable, unless you already have some proprietary process for embedding it in the executable, to get it into your executable, you have to have that source command when you run GDB. So source being the command that includes a GDB script, then you just have to just have the path to that pretty printer file. So the pretty
so the pretty printer's not embedded in the executable.
Not on. No.
Oh.
It's not. No. It's.
But should it be?
It should be. Yes.
Okay.
But that's something that you have to do manually, or you have to write code to do it. So
what sort of code? Is it a linker script or?
It is actually a generated header that copies the entire Python file into an inline ASM block that escapes everything from the Python file, and then there's a few extra directives that I can't remember off the top of my head that just tell it to do the right thing. And so, yeah, it's just an inline ASM header that you include as part of your library.
Okay.
And so if you have that as an internal header that gets included in an external header, then that automatically gets embedded into everyone's pretty printer, and then you have some sort of flag that can turn it off.
No. Okay, thank you.
Yes, I should talk more about that, because that is quite important.
Great talk. I think you've more or less convinced me, but let's say I'm starting from nothing. How should I choose which one to use? What kind of considerations do you use when choosing between NatViz and GDB?
Yeah, it's a good question. Assuming you have equal users of both Visual Studio and GDB, right?
Sure.
Okay.
Yeah.
Because I would say, I mean, if you don't have
Yeah.
users,
Of course. Yeah.
yeah. I don't know. I mean, I am typically a proponent of trying to get a small bit of work done early, just to get a quick win so we can continue on. So in that case, GDB pretty printers might be easier depending on what your structure is. If your data structure is quite complicated, GDB might be easier. If it's a pretty simple data structure, NatViz actually might be easier. I would say just depending on sort of at a high level what would take more time, I would do that later.
Okay. Fair enough.
Just to get a quick win. You know, that's my philosophy. Well, I'd love to continue talking about this with anyone who wants to later on. Thank you all so much.